and we are starting a new topic today. Uh, okay, so I'm going to repeat it. We just started the recording. Welcome, everyone. My name is Kader Khan. I'm one of the lead volunteer and the founder of Testoper community. About Testoper community, it's a non-profit community. The way it was formed was working together, people like you. All what we did was, bunch of experienced guys. We came together and we said, why don't we start something and help people to understand about intelligent technology solutions, right? Or the, whatever that is out there, so that they can prepare themselves to better in their career, entrepreneurship and entrepreneurship aspirations, right? So that was the thought process. And then we kind of came together, like Ahmed, me, Krishna, and many leaders came together, and we kind of started this as a non-profit organization. And the only purpose of this non-profit organization is to kind of help you guys to become experts in the intelligent technology solution. When I talk about intelligent technology, today we are talking about Kubernetes, cloud, blockchain, AI, all those intelligent technology areas is what we wanted to cover. As the name suggests, Testoper, so you would actually see three things in it. One is developer, OPER, tester, TEST, then again OPER, operations, DevOps, right? So we are the non-profit developer community to help you guys to become a future workforce, right? By understanding all these different technologies. What we realized as a team was, and we started looking at what does future workforce mean. What is it the expectation of an organizations that are out there who wants to recruit the people? So then we got into the understanding of what is future workforce. Then we started digging into a little bit more details into that, and we kind of realized that it's not going to be easy. It's not like us, right? In 10 years, 15 years ago, what we used to do, we used to learn some topic and we become expert on that, right? But now the expectation of the company is that you need to be expert in some of the areas, but also you need to be aware of breadth of different technologies. And if a company wants to take you from a current project, put you into some other project, the curve of you picking up on that project and developing expertise around that and delivering results, they wanted to shorten as much as possible, right? So that's what is all about, the expectation of an individual to be part of the future workforce. And we took that as a base. And in Testoper community, we said, okay, we are going to organize multiple different programs, right? One is coding and meetup, hackathons, and all these different programs we will do. And each programs will have its own agenda to achieve. But collectively, all these different programs will help you to become a future workforce, right? So that's the thought process. And with that thought process, we kind of started this community, and we have been doing this good work. And all we ask from you guys is, it's a non-profit, right? We don't run for profit. Always ask you guys is to, spread this to your friends, colleagues, and ask them to come and contribute and learn more from both sides, right? As an attendee and also as a presenter and so on. Ahmed was a attendee before in some of the sessions, and today he's a presenter, and we would like to see many of you to do that and become part of the volunteer team to run this non-profit organization to benefit all the community members, in and around Canada as well as globally. So that's about Testoper. And about me, in the industry, around 22 years of experience, and I'm a director at Expo, and I'm one of the founder of Testoper community, and I'm happy to have you all with us today. There is a couple of bookkeeping things I wanted to announce quickly. The first thing is, today we have a lot of people joined into this session from either they joined it through the browser, or in their organization they already have Teams and they clicked the Teams link and they joined this session. Thanks for joining. However, I like to highlight that I'm pretty sure you guys might have been using Slack, right? In the Slack you can communicate and collaborate before and after the event, right? So like that, we also have a channel for you all to collaborate, and we use Microsoft Teams, right? We don't use Slack, we use Microsoft Teams. If you want us to add you into those channels, please send your email address in the chat window, and we would be happy to add you into the channel so you can collaborate before and after, ask questions among the participants and so on, right? So this is very, very important. And then the second thing is, we will also post the WhatsApp link in the chat of this meeting. Those who are interested to join this closed Codeathon WhatsApp group, you can join. So that closed WhatsApp group is only for those who wants to learn the coding and who are attending different coding programs that we do, right? We have a track on Wednesday and also we have a track on Saturday. So both the links, WhatsApp link, we will send it in the chat. Our team will send it in the chat. Please join WhatsApp group if you are interested to join. And the second thing is, please send your email address to us so we can add you into this Microsoft Teams. So if we add you into the Microsoft Teams, this is what you get. I just want to quickly show you. This is what you get. You will be able to see this Testoper community channel here. And you would be, there are different programs and collaborations regarding the jobs. We have Tech Teaser where we discuss about different technologies. And there are, mentor-mentee channels. So you will get access to all these channels. You would be able to collaborate with us before and after the event as well as collaborate among yourself. So it's a very powerful tool, and I would kindly recommend you to join and help the community grow. So with that, I wanted to kind of hand over the session to Ahmed. Ahmed has been with us from the start of this community activities, have helped us in many areas, and today he's going to take an important topic heart, who wants to give back to the community. And I thank him very, very much for taking time and coming here and preparing this session and helping us to, all of us, including me, to learn. It's not normally people do this for making money, but people are doing it for doing good for others. And very few people have that kind of talent. And I really applaud and appreciate Ahmed taking time to do this. With that, I will hand over the session to Ahmed. Over to you. So we are starting this session around 10:40, Ahmed. So 10 minutes we kind of lost. So you are allowed to kind of use, if required, 10 more additional minutes after 11:30 before we close this session.
Okay, no problem. Thank you, Kader. I'm glad to be here. Glad to be sharing with the community. I've personally learned from a lot of people in the community, and I'm glad to be able to give back a bit. Let me share my presentation, and we can start. Just a second. Okay. Let me know if you can see the screen.
Yeah, screen is visible.
Are you able to see the screen?
Yep.
Okay. This is strange. I cannot see the presentation. Just a second. Let me just reopen my PowerPoint. Oh, this is a PDF. Sorry. Okay. Nice. Technical issues from the beginning. The usual. Okay, let's start from here. Okay, so thank you everyone for attending. Just to set some expectations from the beginning, this is pretty much a level 100 course or series for beginners who are looking into learning more about microservices, about Kubernetes, containers, obviously the relation between containers and microservices, and what Kubernetes does and what it provides. So in this first session, and I think it's going to cover around 5 weeks, I believe so, correct, Kader, as far as I know. So in this first part, I will be covering microservices and containers. Again, from a high level, it's not going to be a lot of in-depth information. And it's open for questions. If anyone wants to ask anything, advanced, I don't mind answering. And if I don't have the answer, I will get back to you for sure. As Kader mentioned, we have the Teams channels where I can always follow up on any question. Okay. Just a little bit about myself. My name is Ahmed Harb. I have around over a decade of experience in areas like Linux system administration. That's where I started. I got into cloud, DevOps, and now it's more of a DevSecOps kind of thing. Security for me is a big thing, is essential. I believe it should be from the start in anything you're doing, especially in the world of the cloud and public cloud specifically. Automation is a huge thing for me. I believe in the motto that if I have to do something twice, I'm gonna automate it pretty much, because I might have to do it a third time and a fourth time and so on. Containerization and microservices has been a big thing for me, and Kubernetes obviously is a given if you're gonna get into microservice, and we will get to that. and why I believe that's reality. And that's not just me. This is pretty much you can see the whole tech market is leaning towards that. I'm the founder and owner of Code the Cloud. I have my own company, as well as I'm a senior cloud and DevOps consultant with ObjectSharp. ObjectSharp are Microsoft partners. It's an amazing company to be with. Has a lot of skilled talent, a bunch of MVPs as well. They're located in Toronto, and anyone who's interested in working with a Microsoft partner, I would really advise you to look at ObjectSharp. You can find the link to my LinkedIn profile as well if you're interested in connecting, and if anyone wants to send any questions, I will do my best to answer and help out anyone who's looking into getting into the market, especially if they're new in the country, because I'm pretty much new in Canada. Even I've been here for only 2 years. I've been through what many people might be going through, and I understand that, and I will do my best to help as I have been helped by others as well. So the first session, I'm going to get into the definition of what microservices are. Okay, and as you can guess, it's pretty much all in the name, right? In the traditional way of things, you had this heavy, bulky monolith, as they call it. It's been I've been there for 10 years in the past. It's really a nightmare from an operation perspective. It's really difficult to scale. You cannot scale one part at a time. I would not be able to scale only, for example, service 1 or 2. I'd have to scale the whole thing because this is all running on a virtual machine or a physical server. Additionally, it's really not very robust to fix issues. It's very difficult to pinpoint the problem and the culprit in this case because all of it is bulked together, right? I don't know if my machine is having issues for service 1 or service 2 or 3. Let's assume this is on Linux. Is the kernel that's missing for this service? If I update this kernel, will it impact the other one, right? So it's really difficult to deal with. It's not really as agile as you want. There are so many dependencies in place. You cannot really update or patch a small piece of this or add new features easily. If you're going to plug in an additional service, you have to think of the impact on the others. And because all of it is living on the same virtual machine, they're pretty much all sharing that same machine, right? And all the dependencies in there. And too many dependencies may lead to a really bloated application and system, especially from a security perspective as well, right? Because if you have one service that has a vulnerability, pretty much everything has a vulnerability on that host, right? It's really pretty much a nightmare that's how I'm going to describe it from an operations perspective. I'm more from an operations side. And this also leads to a very long release cycle, right? And I'm not much of a tester, but I'm sure we have a lot of experts here. If I'm gonna again add one service or I want to update one of them, I have to test all of this. It's really difficult. I have to actually deploy it somewhere. Getting it deployed is difficult. Testing it is going to be difficult. If any issue is showing up, also pinpointing that issue is going to be very difficult. So all of it goes together and leads to a very long release cycle, as opposed to dividing this up to microservices. Then I can work on each on its own, and it's very easy to test. And we will get to that part. Okay, and it pretty much all of this summed up it just hinders your innovation, right? You cannot figure out who broke what in the code. It would lead to very long cycles, and since the cycle is long, adding new features is really going to be a nightmare for everyone, right? Like and innovation pretty much will be a nightmare. So it's very difficult. Excuse me, it's very difficult to deal with, right? So now if we take that monolith and we just pretty much divide it into these services and we pretty much end up with microservices, right? And the ones that need to speak to each other. They don't have to all be hosted on the same host. And they're pretty much loosely coupled. The definition usually, or the words you hear about after the word microservice, you always hear loosely coupled small services. I would like to keep small between quotes because it's not really about the small size. It's not just the fact that I took a service and I put it in in its own container or whatever. Because again, I'll get to that as well. But microservices does not equal containers. We will get to that point. So it's not about the small size. It's about the fact that it needs to be a manageable unit of functionality and being deployable in an independent way, right? So think of it in a way that in the old way of a monolith, one host going down is like, you pretty much lose a big functionality or there's a big impact on your mission, on your system, right? And working with one of these, it's as if you're taking care of a pet parrot, and we know how expensive parrots could be, as opposed to pretty much in the world of microservices, you can look at them as pretty much like your own, like a poultry farm. And excuse my, it's a bit of an analogy here, right? Like, so you have that pet parrot, which is the monolith that you're scared of anything happening to it. It's very difficult to take care of it. You have to care to every need. And at the same time, in the case of microservices, you just think of it as a poultry farm, because when I replicate all of these, I have multiple. Obviously, you'll not run around one of them. You will have HA in place, right? It will be easy for me to replicate it. It will be easy for me to deal with updating one of them without updating the others. At the same time, if one of them has an issue, I lose a replica. It's like, in the poultry farm, when they lose a few chicken, they don't really, it's not going to impact their whole business, right? Pretty much, if you want to think of it that way. At the same time, you can scale these independently, as I mentioned, right? Let's say service 1, I know will get a lot of traffic. I'll have 3, replicas of it. Service 3, I'll have 2. Service 4, I need only 1, or there is some limitation that I cannot run multiple. Maybe some services can only run in non-HA mode. This is reality. It happens. So this allows me to do that, right? And at the same time, that pretty much means that I can deploy and scale each of them on its own. But please avoid the distributed monolith, as they call it in the tech world. So if I'm gonna treat each one of them as a monolith, or I keep it as a monolith, so I take an elephant and I fit it in a container. And then if I do a scaling on this, or I update it, it's going to break my whole system. That's pretty much, you're building a distributed monolith. You're not building microservices. So you need to be careful when it comes to that. Okay. The big advantage of microservices, there is very clear ownership and accountability here, right? In the monolith, you are pretty much a bit lost, especially I'm going to talk from an ops perspective, right? From an ops perspective, my word was like, okay, there's some issue. I identify that it's related to some services running their own application. I don't really have the visibility on that. I go tell the app team, then the app team says, no, this service is developed by some other team or the other team. And, there's this whole, finger pointing going on, and the accountability and the ownership of it is really difficult. At the same time, in a big enterprise, also, every business unit or every team might be paying for the resources. In the world of microservices, you can identify that, right, easily. In the world of a monolith, you have to build some chargeback model and look at there are solutions that cost a lot of money to actually identify the processes within that server or that host, and which one is using how much of the memory and the CPU. And it's really not very efficient from management perspective. Plus, the actual usage of the host is not very efficient, right? So the microservices need to work together. They're often handled by different teams, so they are encouraged to work closer, right? At the same time, everyone is accountable for their own service or multiple services, and it's easy to identify who to speak to as well. I'm not going to speak for project managers, but from a project management perspective, that probably also makes your life much easier, right? Additionally, your innovation is much easier. It's faster. You can add new features, new microservices as well, right? Let's say I want to add a new feature. I can update one of the services, then identify, okay, maybe the new feature will be, more reasonable to be its own service, right? So you want to maintain the microservices, architecture, right? Again, don't create distributed monolith, right? Multiple of them. So that's going to be a bigger issue. Actually, it's way worse than a single monolith. Okay. Additionally, not all the microservices, by the way, need to be from the same same language, right? Using the same programming language or the same packages, same libraries. So you pretty much have the flexibility of using the right tool for the job, right? So let's say Service 2 needs to do some data analytics things. Probably Python will be the best option for that, right? Another service, maybe Java is the best. Again, keep in mind this relates to the fact that there is ownership by different teams, right? So maybe certain team has a certain preference for a language. They have certain skill set in there. They would be more efficient in building a Java app rather than Node.js or whatever, right? At the same time, there are certain services or certain services that need to deal with data. Python might make sense. Other services might be a web server, right? I want to expose certain APIs. Then okay, I will pull out that web server and have it on its own. Some of them will be a front end with Angular and so on. So you get the idea, I believe, so, right? And the last thing is it's much faster release. And you can pretty much, if you think about it, especially, and not especially, this we'll get to that point. It definitely has to be in containers. If you're in containers, you can pretty much release in minutes. You don't have to wait weeks. And in minutes, I'm not talking to production to be realistic. But if you need to do any testing, any dev, any lab work, any QA even, it doesn't matter. It depends on your own way of doing that in your organization. But you have pretty much the technical ability to do this release really faster. At the same time, especially with something like Kubernetes, you don't have that big reliance on let's say ops. You have the platform. Additionally, the fact that Docker is pretty much, or container runtimes in general, are made in a way that they're cross-platform. So if you have a Docker file, a Docker image that you have built, a container image that you're running on your system, technically it should work on another system to a certain extent. There are limitations to keep in mind, but generally it should be easily transferred somewhere else, right? And plus, even you can do your own testing, right? If you're doing some basic stuff, the dev can do the testing on their own machine for that container, make sure it's running, do their own test, and then send it down the pipeline to test in a dev environment. And if they have their full control over that with the CI/CD, they can get it in place in their environment in dev, which again, that's a different topic, but there should be parity between environments, right? So your dev and QA and staging and prod, they should all be the same. Maybe the scale is different, the number of replicas, the number of nodes running in the Kubernetes cluster, or number of hosts is less because you need less resources in the smaller environments in general. But you should have the same parity, same versions. Everything is the same because the kernel is going to be shared by these. So you need to make sure it's the same parity. So you are 100% sure when you test in dev that it's going to go through well in QA and so on, right? You promote your image. There is a process to it. We'll get to that as well. But pretty much, I think you get the point. And it's not all a dreamy situation. It's all roses and and all. So there are certain challenges to keep in mind. Microservices pretty much the interoperability between them, as we said, there might be ownership that's different teams, different members in the team as well, working on different microservices. That's an advantage. At the same time, it carries a disadvantage because it exactly going to reflect your team's ability to work together, right? So because of the fact that the microservices, different ones are often owned by different teams, if they cannot work together in microservices, the microservices will not work together either, to be frank here. So you cannot expect microservices to transform your organization. You're not working for the Autobots. So keep in mind that your organization there is a cultural transformation, and this is probably the last point here. That comes hand in hand if you're from a monolithic setup where there are silos, different people working on things. You need to have a cultural and mentality transformation that goes with that, or else your microservices will fail because they definitely gonna mimic how your business works. Okay. The other challenge is actually making microservices truly stateless. And I maybe in a few presentations ago, I gave a bit of a statement that could be controversial, but everyone keeps saying that microservices have to be stateless or whatever. I personally think that's a bit deceiving. An application can never be stateless. You can claim whatever you want, that it's impossible for an application to be stateless because it has a configuration, right? It always has a configuration, at least, even if it's not keeping record in any DB or anything. The configuration itself is still considered state, in my honest opinion, because when you deploy a microservice, unless that config is in place, it's not going to work, right? So that's pretty much something that's static. It's a state that I'm a state of my microservice and how it needs to be able to function. It's just about the definition of state, right? If we're going to define the state as the actual, sessions and all of that, then yes, it has to be stateless, but it's not the microservice. It's the process of that microservice that needs to be stateless. So when I run a process of service 1 and a process of service 2, or 3 processes of this and that, of every service, these processes need to be stateless. So if it goes away, like a chicken in a poultry farm, I don't lose my business. There's no impact, right? Because my state should be on should be able to, my microservice should be able to recover from that failure, because either my state is in some form of persistent storage or some form of DB or data store in the back, and that is outside my microservice or its own microservice. Some people venture into running DBs on Kubernetes. I don't really recommend that much. If you're on Azure Cloud, you have Cosmos DB, which is amazing to use. SQL, whatever, whether you're using SQL or NoSQL, there are a lot of cloud solutions that you can leverage. Anyways, so this is the general point I wanted to make about the word stateless and microservices. So we need to identify exactly what it means, right? The other thing is the challenge of having these decentralized transactions and data management, right? As we mentioned. So these transactions between the microservice, because the process itself of the microservice needs to be stateless. The microservice needs to recover from any failures, right? Nothing is perfect. You will have failures. Replica might go down. You need to bring it back up, or you need to use Kubernetes, so you don't worry about that. It's self-healing, right? So the point is, you need to use some form of data store that would allow you to coordinate these transactions between your microservices, right? If it's a DB you're looking for, you have Azure SQL DB, a managed SQL instance from Azure, have a fully private one, Cosmos DB, Redis cache for quick caching of transactions as well. You have your own pick. You can also build your own, right? Azure also has MySQL, Postgres as a managed service. And again, you can build your own. You can rely on-prem. Latency might be an issue, but whatever you prefer, right? An additional thing is the performance and the reliability of this distributed system, right? So you need to maintain a stable performance, because when everything is in a monolith, they're all close together, they're on the same local host, you might be relying on that, right? So you need to make sure that when you plug them out, and as they call it, strangling the monolith, when you start doing that and plugging every microservice out, you need to make sure that latency doesn't impact things, right? And that's where probably testing comes in as an essential thing. You need to make sure that that performance is maintained, is stable, and it's going to be a reliable distributed system. And doing that pretty much requires a lot of planning and proper deployment of things as well. You need to make sure. For example, I'll give an example. Like in Azure, you have Canada East and Canada Central region. You cannot, it's not really reasonable to take a microservice, like strangle your monolith. Your monolith is in Canada Central. Take one of them, take out one of the, what you believe would be a microservice within the, carve it out, and then send it to Canada Central and expect the same performance. You're talking cross-region. The latency addition is not huge, but still, that's cross-region. Troubleshooting that will be an issue as well. So be realistic and plan it properly ahead of time. And again, don't do that in production from the beginning for sure. Okay. Additional thing is the operational complexity that it adds. Right? There is a very steep learning curve to microservices, and again, the cultural changes that need to happen. That's gonna be difficult in the beginning, but at the end, I'm 100% believer that everyone will benefit from it. There's huge advantages, but that brings in a lot of operational complexity to deal with microservices. The orchestration of these microservices, the deployments is going to be a different model. I'm not just deploying to one host or a few hosts, the whole thing, right? I'm deploying multiple services. I might scale multiple services. I might change multiple different services at a time. The monitoring of that, the logging, what do I do with that, right? There's a lot of moving parts there. There are tools that are required to better automate that, to deploy, to operate and monitor your microservice environment. And it's, as I mentioned, it's a very steep learning curve. I'm not discouraging anyone, but it is a steep. You need to be realistic that it's going to be a steep learning curve if you're moving from a monolith to a microservices approach. So the other thing is, one more thing to mention also, like if you're going to carve out microservices from a monolith, especially a legacy old app that you have running on-prem, I would really suggest to, if you're going to move to the cloud and your aim is a cloud native situation or setup or architecture as the end, you need to go through a few steps, right? First thing, you would do a lift and shift, probably, to be realistic. You move your service as it is to the cloud. Afterwards, you can look into a more, strangling your monolith piece by piece, carving them out. And that might require code rewrite, right? And it's nearly always required, to be honest with you. It's not a might, especially if you're moving to a fully new environment like the cloud from your on-prem, right? Again, not discouraging anyone. It's a huge disadvantage, and everyone is going in that path. So I advise everyone to also do that, to be honest with you. Especially, nowadays, like with the whole COVID, the cloud has proven the fact that the reliance on the cloud, or the existence of the cloud, has pretty much saved technology for everyone. To be honest, to be very frank there. So you need to go through the cycle, right? So you cannot directly jump from. I would not advise you move your legacy app directly to the cloud into microservices, right? I would advise you move it to the cloud, start leveraging the cloud DB or as data stores, and slowly get into the services, the cloud native services you can have in there, while carving out the microservices and leveraging the cloud for that. And eventually you will get to that end state that you want, a fully cloud native solution running in whatever cloud preference you have, or even multiple clouds, because cloud native is by standard should be transferable between clouds, right? As I mentioned, while you're doing that, you have to discover these services, right? You have to strangle that monolith. So finding out that microservice to carve out the right piece out of the monolith is difficult. So take your time, but I advise to get there, and it's really a big advantage.
Hey,
yes.
Ahmed, Krishna here.
Yes.
So I just want to ask a key question that's from Pankaj, right?
Yes.
So can you share some examples of like 5 or 6 services on the monolith and microservice, so that it gives some context for the users. Pankaj, you want to just share your question if you're not able to articulate properly?
Yes, thanks, Krishna. So actually, I want to know like a real-time scenario where the services are running in monolithic and when it transfer to the microservices architecture. So what are the difference and what are the service and how they are running?
Okay, I haven't really set up a slide that like pretty much depicts that. I can give an example. Think of a bookstore, for example, right? In your bookstore, you have that front end. That's going to be running, let's say Angular or whatever front end you're going to be using, right? You have a service or a piece of it that actually speaks to your DB. That's holding all the data for that bookstore, right? You have another piece that's for your shopping cart. You have another piece that does the calculation for your shipping costs, for example, right? You have another piece that handles the user sessions and the users that are logging in, plus the user information, right? And again, that's also linking to a different probably table or a different DB, right? The DB itself is also a service. So the monolith might pretty much be all of that packed in one, right? You're going to pack all of these. You're going to pack your front end, your shopping carts process, everything is running in one host under the same as different services. Even if there are different services in a Linux machine or a Windows, different processes, but they're still all packed together, right? And closely in the same one. So if I want to, let's say I'm getting traffic on my front end, right? or I find an issue with my shopping cart. There is some problem. What do I do there? I have to deploy the whole thing, right? It's very difficult to only do one fix. In the microservices world, this is going to be my front end. This is going to be my shopping cart. This is going to be my this is my DB, for example. This is my user session service that's dealing with the user information. This is the inventory service that's dealing with the DB as well. Where there is does that answer your question?
Yes, pretty much. So thank you.
Okay, no problem. Yeah. Okay. So yeah, as I meant again, the last point here is the fact that the most difficult part is going to remain. I've repeated this a few times. Is to deal with any organization is the culture and mentality changes. Right, silos will not work well with microservices. That's something you need to move over and so you can advance and get into the microservices worlds. That's the end of the first session in general, just a high level about microservices. Does anyone have any questions? Should I go ahead?
Yep. So I don't see any questions, Ahmed. Yeah, you can move on to the next topic. Just a couple of points. Just want to make sure. Guys, if you wanted to join with Microsoft Teams, please send your email addresses in the chat so we can add you into the team so you can collaborate with Ahmed before and after the session, right? And the second thing is there is also a WhatsApp link posted in the chat. This is only for the closed group of Codeathon attendees. So if you're interested, you can also join that WhatsApp group. So let's use the chat to collaborate there. Over to you.
Yeah, no problem. So now I'm getting to the containers and microservices, the relation between them. I'll start by pretty much defining the name or what containers and what they are, and what's a container pretty much. So the name comes from a shipping industry. To be honest with you, that's you can see it even in the logos and everything that's used. So the one-to-one or a bit of an analogy here, and this shipping industry, origin of the name has led to an aquatic theme for the domain, pretty much. If you see this, Kubernetes even and all of that, a lot of tooling around that have a bit of an aquatic theme. The fact is that in the shipping industry world, containers are pretty much portable, right? They can be used on any supported ship, right? In the software industry, container is also portable. It can be used on any supported system, as long as it has the container runtime. At the same time, when it comes to the shipping industry, a single ship can hold many containers, right? And in the case of software industry, there's a wide variety of software that can be packed into one container, right? But again, the best practice to have one process running in each container, obviously, or one main process in there. Another thing is the shipping industry. In the shipping industry, the containers, they isolate the cargo from each other, right? Every container might have different type of cargo. They're isolated from each other. In the case of software industry and containers and in the software realm, a physical or a virtualized machine can hold many containers, right? The other thing is, a wide variety of cargo that can be packed into a single container. In the terms of the shipping industry, while in the software industry, again, you're isolating the execution of one container from another, right? So I will really not delve much into the history of containers. You can find a lot of information. If you just look up the history of containers, you'll find a lot of info. I personally, like to be honest with you, it even came before me. It doesn't really, in all honesty, I think it doesn't really matter much. We are benefiting from the legacy that brilliant minds have built from the past, and we need to focus on what's present and keep up with the new technologies, because literally every other day you will see new things coming in, new updates, and you need to keep up with that. unless you have the preference of history. That's again also it's good to have an overview. I would encourage you to look up history of containers. You'll find a lot of information. But in short, it really started back in 1979, pretty much in the Unix world. The whole change root, ch root option or feature where you can jail a user into its own into its own namespace. Okay, and it's the same concept that went into something called C groups and LXC and Linux containers, and from that Docker eventually came out as the first official container runtime. Just if you look at the the way that it would work in the container world. Previously in the virtual machines, you would just have the infrastructure. Then you have your virtual machine with the OS, and you will add your services, right? In the container world, you would just add a container runtime. There is a bunch of them. Docker would probably be the most famous, most common one. All you need to think of it is you'll add that container runtime, and on top of it, you can run multiple containers. Each one of them having its own app, its own binaries, its own libraries that are isolated and separate from the other, right? So they are smaller. They have less overhead. So they only contain the application and the libraries that run, but they still run on the common host machine, the kernel of that host machine, right? So that would abstract the differences in OS distribution and dependencies. I might have a Linux. There's still the kernel is an essential thing. There might be differences, but as long as you make the same library, the same kernel modules, and the fact that when you set up your cluster, there will be some consistency in there. You as long as you add the runtime, that contains anywhere on any host, because this host OS is now abstracted. The runtime is just in between, right? So you don't really have to worry about that, and that's how it makes it very, very easy. But keep in mind, a lot of people say like containers is the new virtualization. It's not really that. It does not replace VMs. They work together. They do not replace each other, because this host is going to be a VM. Okay, you're going to create VMs, and then on them you have a Docker runtime or any runtime of your choice. Again, Docker is probably the most common, and you run your containers, right? So it's a container is simply just a way to pack your code and dependencies together, and you can run due to the legacy of it depends on C groups and in Linux. So you will have your own network space and process space for your container that's running. And if that sounds familiar, again, as I mentioned, it's a very similar concept to the VMs, right? So you pack the OS and your software together to run in isolated instances as VMs, and they can run anywhere you have that hypervisor, right? Which is the layer between the VM and the kernel, which is emulating these system calls to the physical machine, right? To the hypervisor, the host. So again, you can have multiple VMs, different OSs on the same hypervisor. So as an analogy, they're similar. Again, they don't replace each other, as I mentioned. Okay, and that's pretty much it. The other thing is there are a lot of container runtimes, as I mentioned. There is runC, containerd, Creo. Docker is the first, and it's the most famous and the most advanced, or the most developed, I'd say, with a lot of community, backing it. There is always there's also an enterprise version of it, but again, pretty much now the relation between containers and microservices. So containers pretty much empower microservices. You need containers for microservices, to be honest. I am going to say this clearly. However, to be clear, you you don't have to have containers to have microservice. They do not equate. So containers does not equal microservice. Microservice does not equal container. And if what we saw before, the service one could be an elephant that I didn't carve things out properly, right? I didn't do a proper service discovery. I didn't carve out all the things that need to run their own process and put them on their own. I just stuffed that elephant into a container. You can do that even in the shipping industry, right? You can stuff an elephant in there. That's gonna die eventually, right? So we don't want to harm any elephants; they're endangered. So you need to keep that in mind. They're not equal. So you need to properly build a container that is actually hosting a microservice based on all the points we have discussed before, right? You have to keep all of that in mind, right? So not every container is really a microservice. So you shouldn't do that, fit an elephant into a container, right? Microservices are best built by leveraging containers, as I mentioned. Right? You can build microservices on VMs, but would that be agile? Would it be easy to manage? Yeah, I think you would still be in the same situation of or some of the issues of the monolith, right? Would it be utilizing the VM properly, right? Like currently, you might be running a VM with a monolith on it. You might be using 50% of that VM's resources, right? If you have containers, you can fill in like Tetris. Everyone has played Tetris as a child, right? You can fit the holes and put your containers in there. That would take the most advantage out of your VM. Obviously, don't choke it, but instead of 50 or 60%. I can, if I'm gonna take that monolith and run another thread of it on there, I'm gonna fill the VM or I'm gonna have issues, right? But if it's microservices, I can run, 40% more containers on it, and I'm hitting 70 or 60 or 80% of the 80%. 60 is still not that good. Say 80 up to 90 even of the utilization of that VM, right? So that's obviously better. Then what about patching that VM? I still have to patch that VM. I still have to deal with it, make sure it's working fine. Obviously, in the container world, you have to do that, but it's abstracted, right? You just do one host rather than having to do, let's say, if I need 5 replicas of a microservice and I'm going to run every replica on a VM, that's a big operational overhead. It's really ridiculous from a cost perspective as well, because it's not a microservice if it needs a VM, to be honest with you. So at the same time, to take an example, Google for, I'd say, nearly 15 years now, they have been running several billions of containers, to be honest, every week. Every week, they need to deploy billions of containers, they update, they patch. Can you imagine running that on VMs? Who would be able to run billions of VMs, right? Luckily we have Azure and AWS and Google and all the clouds that are available. They run for us millions, maybe billions of VMs, but I can only imagine how much of a overhead it is from their end and how many teams are dealing with that. But they don't expect you to run a VM for every process. That's going to be ridiculous, right?
Yeah, Ahmed,
so,
yes. Ahmed, sorry, you kind of addressed that answer. So there was some questions going on in the chat. What's the difference between running an application on the VM versus containers, right? And
yes.
One of the main difference that has been discussion going on is obviously in case of VMs, you have a guest OS, right? So you have 2 OSs. In case of containers, all the applications share the same OS. So obviously you reduce the overhead. And on that context, there was another question came up, what if you have to install the container on top of a VM, right? Is there any application where you wanted to install your containers on top of a VM? Right?
You don't install containers, right? You install the container runtime, which I probably already addressed, right? You have the container runtime, you just deploy your container there. I will show a small demo. It goes up in less than a second. So you don't. So again, it really removes all that overhead, right? Containers will run on VMs. They go hand in hand. You need VMs, you need an OS, you need the container runtime on top of it, and they all go through it, right? But they just create isolation at a higher level, which is from a binary perspective, from a library perspective, from a process perspective as well. They have their own namespace for processes, their own namespace for the network as well. To a certain extent, obviously, they still share the nodes, port range, and all of that. The IP also, they will be natted through it, but they have a bit of isolation in terms of that, right? Let's say I'm running 2 processes that need 2 versions of Java, right? You can do that on a VM, obviously. But that's more overhead for the operation team to manage, right? Rather than packaging that all up in my container and keeping them isolated, and I can move it anywhere, right? If I move it to another VM that doesn't have my Java, I'm screwed pretty much, right? It's not gonna run. But if it's part of my container, I've included all the libraries I need, all the dependencies I need in my container, I'll move it easily, regardless of the VM, as long as it has the Docker runtime and the OS obviously supports that runtime and the container image, right?
Let me maybe ask this question this way, right, Ahmed?
Yes.
So, if I am an infrastructure guy, right, and I wanted to build an infrastructure for my company, and all the services are developed using microservice architecture, using containers or whatever, right, that you explained. And in that situation, what do? I buy a bunch of servers and then I directly install the Dockers or something, and then I start deploying everything, or do I, install VMs, and then on top of VMs, inside the VMs, I install the container infrastructure, and then deploy the services. What would be the right way to go?
Kubernetes, because even if you do that on a lot of VMs, I'll get to that towards the end. But
just want to
who's gonna maintain this 200 containers or 300? So who's gonna deal with that?
Versus that. See, each if you want to look at containers, Docker, there are three key concepts you got under: C groups, namespace, and chroot, right? So at the end of the day, you still need to have virtual machines to host those containers using some sort of orchestration layer for Kubernetes. So I really don't want to be learning this one. I don't want to get this versus that, but I got to tell you, there are certain value which virtual machines provide, which is very strong security boundary, right?
Yep.
On the container world, microservices, one process can be run. So there's still you need virtual machines for a number of services. For example, a lot of enterprises, they might have a bunch of virtual machines that are dedicated to a specific workload, and they define a very strong security boundary about it. Okay, as of today, you should not be running a database in a container. You might run services on it. So it's not this versus that. These have to coexist. Containers do give you additional advantage of hosting microservices at scale, but if you're having any stateful application, pretty much you end up using a virtual machine. So that if you have that mindset, then you can build a coexisting pattern, right? So
yeah, sorry, Krishna. Quick question is: do I have to always install the container infrastructure, right? The Docker, whatever Kubernetes infrastructure on top of VM, or just to install it on the bare metal, which would be the optimal way to go, right? That's the question.
So who in these days is using bare metal at this point?
Yes, exactly. That's my answer.
I mean, why do you want to even think about bare metal as even existing?
Or let's say when Microsoft is providing the infrastructure for the containers to us, do they host it on top of VM, or they host it on top of?
Absolutely, everything is virtualized.
Yeah, everything is virtualized.
Everything is virtualized.
Okay, got it.
I got to tell you one. Sorry to take the time off on this one. See, people have moved beyond containers now. Okay, so container by itself brings other challenges. See, now people are looking at like FAS, right? Function as a service. What Ahmed is trying to explain to you guys. Hey, these are the things how you're able to host a container in an ecosystem. But at the end of the day, containers plus the end customers, the value they're going to use. So I don't want to take too much time, but yeah, those are the key points accentuated.
Okay. I have some follow-up question, but I'll not steal the thunder. But
no. So as I was mentioning, like Google are deploying billions of containers a week. Doing that for VMs, whatever system automation you use, that's probably not even possible in a week. So the containers have a quicker start time. They're easier to scale. So that definitely would help you in all your needs for scaling microservices independently and getting them up and running, testing them quickly. Again, also the independent updates, the releases of images, you can work on every image on its own, right? You can release it on its own, you can update it on its own. That also answers your needs for a microservices environment, right? Also, it gives you an isolated runtime environment that can be tailored for every microservice, right? So, again, if you're going to use a different tool, different libraries, you can do it in its own container, right? So that would allow you to build different microservices using different tools. At the same time, you're sharing the host for a heterogeneous application, right? So your applications, your full application, even if it's microservices, they still need to deal with each other. They need to communicate with each other, and you're leveraging your same host in a better, more optimized way, right? So it's more cost efficient for sure. So keep in mind that if you're going to leave your configuration baked into your image, if your container image, there's nothing stopping you from putting multiple services into the same container, right? The same container can also be a monolith, as we said, the distributed monolith. So please, I keep repeating that, but please avoid that because it will be a much bigger issue than having a monolith on a VM, to be honest. Okay, so a container can be as bloated as you want. A container image can be few megabytes, 2-3 megabytes in size, or it can be a few gigabytes, to be honest with you. So it's up to you to choose, right? So I'm gonna run a small Docker demo. It's really basic stuff. It's not gonna take a very long time. I already have Docker running. And I'm running actually Docker for Windows. So this is pretty much just using the internal port on my local host to talk to the Docker it's a runtime. And you will see it's not really feasible to just use Docker, and we will get to that point. We don't have much time. I'll try my best to cover as much as possible. But you can if I just thing, right? So it's just gonna public images, right? And it just gets the image and runs it for me, right? There is a lot of. I don't think I have much time to run everything I need, but so I just want to do some tests like here. I'll just give you a few examples. You can pass like environment variables to that, right? So if I'm gonna pass an environment variable called username equal test, for example, right? And I just run a busybox one, and I just run the command environment on it when it starts up. I'm running a busybox container. It's also not finding it, it's pulling it out of there, and see, I've passed in the environment variable to it, right? So you can do a lot of things. I'll run something more practical a bit, right? So I can expose a container on a systems port, right? So I'm gonna expose it on port 8080, and I'll map it to port 80 because the container will be running with that. And I have actually I have a small file to update that, okay? And you can pass a volume to it as well, okay? Before doing that change, just to show you the difference, I'm just going to run the Nginx image. It's going to pull that from publicly. I actually already have it available. So now it's running. If I go to my browser and I go to localhost 8080, I have Nginx running, okay? Actually, that was cached. So this is pretty much Nginx. Did you even measure the time it took to bring it up? You had my points here. I'm seeing all the access logs as well. I'm able to see it. Right? So here, let me just
sorry, would you be I know that today you're running out of time, but in your next session, would you be explaining the team how to kind of install from the scratch to get to where you are, right? The demo.
So we can do that, Kader, but I'm trying to, give the things that are not really easily available on the internet. If they just look up Docker installation, they will find all the steps needed. Docker is really well documented. I've added some links to that. If you see in the PowerPoint, there is a link here to the full Docker CLI reference, and from there on the left side you'll see it very well documented. Installing it on Windows, on Linux, on Mac, wherever you want to install it. It's just a few steps and it's very easy. I think it's better to leverage the time to share things that might not be easily. Even the stuff that I'm doing is easily available, but I'm trying to just,
yeah. So I just want to make sure that the team here, for those who do not know how to install the Docker to get to the place where you are, and what is the instruction to them, right? Of course, they can ask you the questions. There are so many questions in the chat, and I trust
Yes.
that you would answer after the session
Yeah.
to the people, and also the people. Please send your email address so we can add you into this chat access or whatever Teams access, so you can collaborate with Ahmed after that. Okay.
Okay, so what I'm gonna do here, I have a local file on my machine that has just an index file.html, right? So I'm gonna, mount that. You can also pass in a local volume and mount it into your container at runtime, okay? And I'm gonna mount it in the location where the default index, which we just saw for Nginx usually lives, right? So I'm gonna run this container with, sorry, that's my bad. That's my bad. The image name should be at the end always. So, okay. And it's up and running. Just to see here the difference. This is a typical one, right? And I just passed to it. Again, this is probably cached. Let me new private window. Oh, I think it did not mount it. I'm not sure 100%. So it is working. It should be able to mount it. Just a second. So, oh no, sorry, this is my bad. I don't need to give the full. I'm just running this. And if we go back to this one and we refresh again, it is not working. That is strange. User share Nginx HTML. Oh, okay. That's my bad. I am mounting it on the wrong directory. Okay. So this is just /HTML. Okay. I think this one should be working now. And as you can tell, I have this file, right? So this is a local file where I've just created an index.html file. And I can actually, you can update the container and run and while it's running and commit it and then create an image out of it. It's really very feasible to do that. There's a bunch of more things I wanted to show, but I'm just gonna get back to the presentation to quickly try to cover the last remaining points. Again, I think when I share the presentation, you can go through this. This is from Microsoft. So it's gonna be the same cycle of what you usually do. So you're gonna continue to code your app, but the difference is you're gonna write a Docker file to create an image. Then out of that, you create your image. You can run it locally. Using Docker Compose is optional. I don't really think it's really worth much of your time because, again, you will not use it in production. You'll end up needing an orchestration solution, a proper one. You can pull your base image from the public, again, not advised, or you can, put that in your own local system, again, not advised. You should use a private repository. I was gonna cover it. I don't think we have much time. I will probably leave it to the actual presentation for AKS. I will add ACR in there. And again, your image is there, so anyone can run it. If someone else is sharing the repo in the company, can also run that container and test it out, right? And then either you are satisfied with it, you can push it to the master branch or whatever the code that you have changed, or you can just continue developing as you need. Okay. So again, you can go to this link, you'll see this image, and you will find a lot of information and details of it with some examples of you can follow. Microsoft has really documented a lot about microservices. Okay, so I was gonna cover this whole idea of using private Docker repository, but I will keep it for AKS probably. I was gonna also show a bit of building the image and pushing it to a registry. Again, I'll leave that for a different time. So I'll get to the main point here. The need for something more, right? So the fact that if you're going to follow this with Docker, even Docker Compose or whatever, you can easily manage hundreds of containers on a 20, 30, 40, 50 nodes, let's say 100 VMs, whatever, and you will have a few hundred containers. I don't know who can keep an eye on all of that, but on the VMs themselves, it needs a full team. So imagine the containers. But what's next, right? Like, is that sufficient? It's actually microservices. It's not service, right? So we're not only dealing with one. We have a lot of different microservices. We have a lot of things to deal with, and everyone will have its own replicas. It will be on different nodes, and you need high availability built into there, right? Because even if it's a monolith or a microservice, you need to think of high availability, right? What about the resource allocation of that? The state of your host, right? If the VM goes down, what happens? All my containers on it are gone. What happens to them? Where do they go? What goes on there, right? What about the scaling out, the fault tolerance, the high availability? If I want to scale, someone has to go to the VM and add more containers of the same image, and then figure out how to link it to the network, and all of that connectivity. It's really difficult to do this on your own, right? The connectivity between these containers as well. Definitely, they're microservices, but they need to talk to each other, right? They need to talk to outbound hosts as well. They need to talk to another VM where your DB is on, as Krishna mentioned, or a PaaS service for DB, or anything you are using, right? Even the internet, you might be pulling from, talking to something remote, right? And what about also your service discovery, right? Okay, you're building containers, but these pretty much are represented as microservices, right? Who's gonna define these services? Who's gonna identify them? Who's gonna route the traffic to them? Who's gonna manage the load balancing? It's going to be a bigger nightmare than monolith if you're gonna do it on your own. What about the configuration as well, right? You need configuration for your app. You need secrets as well. How do you pass them in, right? What do you do there? Persistent storage as well, right? If you saw how I needed to mount a volume, I've done this a few times, and then I forgot the path, and there's an issue there, right? So, and that's a single volume for something very basic. I just only overread the index HTML. What if I want to give an Nginx configuration, right? What if I want to pass something persistent to that will be used, right? What if the service itself, again, Kubernetes does have stateful sets as a resource, or in containers as well. You might have something stateful running, but you need a persistent storage. Who's going to maintain that for you, right? The integration with it, on what basis? How does that work, right? On all the operational things, the management, the monitoring, the authentication, the authorization, who can deal with what container, who can manage what container, who's going to do that, right? How are you going to manage that? So this is where the container orchestrator comes in. There are a lot of them. There's Docker Swarm. There's Mesos from Apache, but by far the most famous is Kubernetes. You probably know that is the buzzword of the century, of the few decades, let's say, not the century, but it's pretty much in high demand, and it's the most used solution for something like this, and it's the best solution, to be honest, in my honest opinion. I obviously, as you see, the time is running out, and I knew that this is going to happen, so I didn't cover it here. But I'll try to explain it, and I will try to avoid this. It's pretty complicated, but this is a very famous tweet that, one time I tried to explain Kubernetes to someone, then we both didn't understand it. So it's pretty complex, but I'll do my best to simplify it as much as possible. And hopefully in the next presentation, I will start getting into it at a level 100, the high-level concepts of Kubernetes, and then the one after it, we will cover the different components of Kubernetes, the different workloads in it, and pods and so on. I will cover that in details. Obviously, not all the details, as much as possible at the high level. And after that, we will get to a bit more hands-on option of deploying an AKS class, and then the managed Kubernetes option. Because once I explain Kubernetes, you will realize the complexity of actually even deploying it and maintaining it. So that's where managed Kubernetes comes in, and AKS is an amazing solution for that. We'll cover that. And eventually at the end, I'm hoping to also cover service mesh solutions and what role it plays as something extensible over Kubernetes, because Kubernetes was built in an expectation that it needs to be extensible, it needs to be extendable, and you need to add other solutions and plug in things in there. And I will cover that in the next presentation, hopefully. And hopefully I've benefited you in this one. I'm sorry for the time limitation. I was hoping to cover the
I know that we had this 1 hour and you need to rush and you were not able to cover that, right?
That's okay.
What I wanted to kind of make sure that we understand. Let's take time to cover whatever that we can cover in 5 weeks. In case if you're not able to cover, we can always schedule additional sessions to cover, Ahmed, right? That's my thought process. Rather than rushing through, let's take time to cover. If it has to extend another couple of weeks to finish the program, we can do that if it makes sense to you.
Yep.
Because I don't want to end up in a situation where there were some comments that were passed out to me here to see, okay, I want to really understand how to set up this basic Docker, or at least give an instruction to set up this basic Docker and work on and so on, right? So
Yeah, Kader, this is Partha. I very recently put together a set of instructions for installing this whole thing on Windows platform.
mhm.
I actually shared it with Ahmed, saying that maybe the participants would want to have this. So I'll send it on to you, and you can then pass it on to the group.
Why don't you send it in our Codeathon channel, right? So this is critical. I just want to make sure that we spend time and we also, make sure that we do things. So guys, in the Teams channel, you can go to this Codeathon, and in this Codeathon channel, you can actually put all the inputs, right? And so that people can collaborate, how to set up the basic things to learn the advanced things and so on. Okay.
Okay.
So let's make sure those who do not have access to our Slack-like Microsoft channels, send your email addresses. We will add you in. Let's collaborate more into this. There are so many questions, Ahmed, that we could not cover today. Maybe you can look at that offline and answer them if you get some time this week before our next session. By the way, Ahmed is going to be with us 4 more weeks. This is not the last session. So in next 4 more weeks, he has plans to kind of cover us in additional topics, as it was mentioned in the Eventbrite. We'll make sure, in case if we are not able to cover in those 4 or 5 sessions, we'll make sure we'll collect those additional topics that you wanted to learn and maybe create a separate session to cover those topics as well. Okay?
Yep, sure.
Any other comments, Krishna, Ahmed, or anyone you want to share? By the way, I just want to also let you know, go to the YouTube and search for Testoper. You will find all these recordings out there. And also in the Codeathon channel, there is a files here. And then inside that, there is an IA track, which is what we do, Saturday track. All the presentations are normally uploaded here for your offline reference, both from the YouTube point of view as well as from the presentation point of view. Once you are in a channel, you should be able to access all of them. So over to you for final words, Ahmed and Krishna. Anyone else before we close this?
Krishna, go ahead. My seniority. If you have anything, I don't really have much to add. I'm really glad. I hope a lot of people have benefit from this. I know it's, as I mentioned from the beginning, it's a level 100. We're trying to cover as much as possible to probably, encourage this discussion, Kader, right? I am aware more questions will come in, more advanced, questions and things like that. And hopefully we will do our best to cover as much as possible.
We don't have to. See, this is what I believe in, Ahmed, right? Yep. We don't need to cover 100 things. Let's
yes, it's not possible, Kader, to be honest. It's an ocean of information.
Yeah, exactly. Focus on 2-3 things and cover the best to it, and then input from the people, and then create an action item to create another session on those topics moving forward, right? So we'll work together on that. No problem.
Plus, Kader, the main thing is to encourage the curiosity, right? So everyone, it's to have that curiosity and look into the features and the capabilities that they bring in, and everyone. We always all have to keep learning on our own as well, right? So it's not possible to cover each and every detail. Even myself, I really might meet someone or deal with someone who have done very different things and had a different approach to Docker. Some people might have chosen not to even use Kubernetes, right? As you can tell, there are other options. So the field of technology is huge, and the amount of technology is coming in are really overwhelming, if I may say that.
That's the reason why we exist, Testoper community, for the developers, right? So we wanted to kind of take one step at a time and help them through the process to learn themselves, equip themselves, be better in their career, entrepreneurship aspirations. So that's why we are here. We will make sure, team, right? We will review through all your questions, Krishna, myself, and Ahmed. And we will respond to all your questions before our next session as much as we can. And also in the collaboration platform, you can ask us questions. We will try to engage. We'll try to cover whatever Ahmed has in his plans for next 5 weeks. And if additional things are required, we will plan for the future sessions to keep our community engaged. And also encourage people and experts here in the call today. If you wanted to, help us learn additional topics, you can always reach out to us. My email ID is testoper@testoper.com. It's pretty easy. You can reach out to me, share your interest, and we can create some topics around that and help the community. And we all of the community will work together, learn together, and grow together. With that, Ahmed and Krishna and everyone, let's close for today's call. And I'm looking forward to talk to you, every one of you, in our session 2 from Ahmed next week.
Thank you. Thank you, Kader.
Take care. Bye-bye.
Thank you. Take care.
Okay.
Bye.
Thanks, Ahmed and Krishna
You're
and
welcome.
Kader.